So, what is the molarity of the solution made by dissolving 7.5 grams of magnesium nitrate in enough water to make 25 milliliters of solution? That will be the first problem, okay? So this I'm going to call it example 1, okay? And I will start working in this part. For the example 1, the problem is asking me, or actually the problem is given me, that I have a solution of 25 milliliters, okay? So my solution is 25 milliliters. Also, the problem is giving me 7.5 grams of magnesium nitrate. And it says dissolving 7.5 grams of magnesium nitrate. Remember, in solutions in molarity and molality, what we have is the substance that is being dissolved is known as the solute. So in this case, magnesium nitrate is the solute because it's been dissolved. So we say solute is equal to magnesium nitrate, which has this formula, and it's 7.5 grams. The problem is asking me about molarity, which is a uppercase M. This is unknown. But what we do know is the formula for molarity. Okay? The formula for molarity says that we need to know the number of moles of solute, and we will divide by the volume in liters of the solution. Okay? That is the main equation for molarity. So, we cannot get molarity if we don't have the number of moles. So the first step will be finding the number of moles of the solute. I repeat, the solute is magnesium nitrate and it's given only the grams. If I have the grams and I want to know the number of moles, I need to use the molar mass to find the number of moles. So as a first step, we need to find the molar mass of the solute. Okay? So, the solute is magnesium nitrate. And that is a chemical composition. Okay? So, with this chemical formula, we know that we have invisible 1 magnesium atoms, okay? And remember that the 2 that is outside the parentheses will multiply everything inside the parentheses, okay? So here, these 2 outside will multiply oxygen and nitrogen. For nitrogen, as you can see, we don't have any subscript, which means that I also have invisible 1 nitrogen inside the parentheses, and oxygen, I just have 3. Okay? So we say magnesium has 1 atom. What is the molar mass of the element magnesium?
24.3.
Did you find the molar mass? According to my periodic table, I know that the molar mass is 24.305 grams. For my element nitrogen, I have 1 inside the parentheses that is multiplying the 2 outside the parentheses, and all this multiplies my molar mass of the nitrogen, that is 14.006 grams. And then for oxygen, I have 3 oxygen atoms inside the parentheses, and outside the parentheses I have the 2, and the molar mass for oxygen is 15.999 grams. In total, I have 24.305 grams, 28.012 grams. If something is wrong, please let me know, because I'm doing it mentally. And this is 95.995. I'm not very sure. Make sure that this is right. Okay? So the molar mass gives me
148.31.
148.31. Okay? That is my molar mass of magnesium nitrate. So right now that I find the molar mass of the solid, I need to find the number of moles. So that will be my second step. Number of moles of solid. So from the mass given, I will get my moles given by using the molar mass. Remember, stoichiometry. So this will be the path. For grams given, you will get the moles of the given by using the molar mass. Okay? That is the conversion process that we do. So we say 7.5 grams of magnesium nitrate and now I'm going to be using the molar mass as a conversion factor. Where am I going to place the number of moles, up or down?
Up.
So in 1 mole of magnesium nitrate, I have a mass that is 148.31 grams of the same substance, magnesium nitrate. You cancel these units, and this gives me 0. This gives me
0.05.
0.05. These are moles of magnesium nitrate. Okay, that would be the first answer. But the problem is not asking us to find the number of moles. It says, what is the molarity? So in the third step, we're going to find the molarity of the solution. We apply the formula for molarity that says molarity is equal to the number of moles of solute divided by liters of solution. Now let's see if the problem gave us the solution in, no, take a look. The solution in this problem is in milliliters, okay? So remember that in these problems, we need to convert from milliliters to liters. So the conversion process, I'm gonna do it here, okay? It's 25 milliliters times. In one liter, you have 1,000 milliliters. So basically, all you have to do is divide it by 1,000, and this should give you 0.025 liters. 0.025 liters, okay? So remember to do the conversion process. You can do it as a first step. Okay, now we're going to take those liters and we're going to plug it into the formula, and we find the molarity. Molarity is equal to moles of solute, which is 0.05, and these are moles of magnesium nitrate. All this divided by 0.025 liters of the solution. How much did you get?
2.
So the molarity of this problem, the molarity of this solution is just 2m. And with this, we finish the problem. Now, in the second problem, it says, how many grams of sodium chloride are needed to prepare 125 milliliters of a 0.037 molar sodium chloride solution, okay? So we need to, going to write the data here. You also write the data in your notebook. So this solution has 125 milliliters and the molarity is 0.037. So molarity equals 0.037 m, and the solution has a volume of 125 milliliters. Remember, you can do the conversion directly. So we say that there are 1,000 milliliters in 1 liter. Eliminate the milliliters with milliliters, and as a result, you get 0.125 liters. Now the problem is asking me to find, let's see, because I already forgot, it says how many grams of sodium chloride. So they're asking me grams of the solute. Okay, let's analyze the problem. They're giving us the molar and they're giving us the liters of solution. According to the formula for molarity, we know that this is the equation. No quepo en este escritorio muchas cosas. This TV occupies like 80% of the desk. I cannot work here. But anyway, this is a formula for molarity. Okay. So according to the formula from molarity, if I have the molar concentration and I have the liters of solution, I can get the number of moles of solute. Okay? But the problem is not asking me moles. The problem is asking me grams. Okay? So the idea in this problem is we need to find the number of moles. Once you have the number of moles, you can get the grams. The conversion between moles and grams can be done by using the molar mass, in this case of NaCl. So let's see. The first step will be find the number of moles. So the equation isolated already for the number of moles is equal to molarity times the liters of the solution. We substitute by the givens. And we multiply times the liters of solution. We already did the conversion. How much is this?
0.004.
0.04 or 5?
5.
5 rounded, okay? Okay. Now, this is number of moles of the solute. In this case, the solute is sodium chloride, so we write the substance. Once we have that substance, we can find the mass, find the grams of solute by using the conversion factor between moles and grams, which is the molar mass. So the substance is NaCl, okay? So we have one sodium and one chlorine. One sodium is 1 times the molar mass in the periodic table, that is 22.989 grams. And chlorine is 1 atom. Remember, if you don't see them, they are invisible. So you have 1 atom of chlorine, that is 35.45 grams. How much is this? How much is the molar mass?
8.44.
58.44 grams over mole. Okay? So, to find the grams of solute, we're going to convert from number of moles to grams by using the molar mass. This is the path that we're going to follow. So we say, we obtain in the step before 0.005 moles of NaCl, and I will multiply times the molar mass that we obtained in the step before, that is, that in 1 mole NaCl, you have 58.44 grams of NaCl. This allows you to eliminate moles with moles. And how much is this?
0.29.
0.28.
0.28 grams of sodium
29.
Okay, 0.29 grams of sodium chloride. And that will be it. That will be the answer of the problem. Now this the third one right here, you will do it as a homework, okay? You will do it as a homework. Now, we're going to do one more example for molality. Let's take a look. Okay, remember what the equation for molality is. Molality is lowercase m is equal to the number of moles of solute divided by kilograms of solvent. That's the equation to find the molality. Now, in this problem, they're asking you to find the molality of a solution prepared by dissolving 150 grams of hexane in 600 grams of water. Okay? So here, the first step is we need to identify the solute and the solvent. What is the solute? In this problem, what is a solute? Remember, the definition of solute is the substance that is being dissolved. What is the substance that is being dissolved? Water, or is it the chalk compound?
It takes H12O6.
6H12O6, or therefore the water will be the wait. Therefore the water will be the solvent. Okay. Okay, that's the most important step because it allows you to arrange the data according to the equation. They are asking you to find the molality. Okay, this is the unknown. They are giving you the grams of solute, that is 150 grams. And they are giving you the mass of the solvent, and that is water. The solute, which is water, they are giving you 600 grams. But take a look. For the solvent, I need the solvent to be in kilograms. That means that I need to convert from grams to kilograms. Okay? So all I need to do is I need to perform a conversion. So the conversion is easy. 600 grams times the conversion factor. There are 1,000 grams inside 1 kilogram. So the answer in the end is 0.6 kilograms of the solvent, which is water. Okay. So the idea of this problem is I need the molality. I don't have the moles of solute. I do have the kilograms of solvent. So to find molality, I need to know the moles of solute. And to find the moles of solute, they gave us only a mass in grams. So with the mass in grams, we can get the number of moles by using the molar mass as a conversion factor. So that is going to be the first step. Wait, because it's not updating. Okay, so now in the first step, I need to find the number of moles of the solute. Okay, and I know the mass, so it's going to be from grams given to moles given by using the molar mass as a conversion factor. So the first step is the molar mass. So this is the chemical composition. So this gives me 6 carbons, 12 hydrogens, and 6 oxygens. I'm going to do the faster method of the molar mass. I'm going to do the faster method. Okay, I'll be rounding the molar masses. So this will be 6 times 12. This is going to be 12 times 1, and this is going to be 6 times 16. So this gives me 72 plus 12 plus 96. How much is in total?
180.
180 grams over mole. Okay? Once I have the molar mass, I can perform the conversion. Okay? So this will be 150 grams C6H12O6 times the molar mass as a conversion factor. That is 180 grams that I have in 1 mole. How much is this?
0.83.
0.83. Okay, now I know the number of moles. So I'm going back to my formula. I know the number of moles. So now I can easily get my molality. Okay, so that will be my second step. My molality is going to be equal to moles of solid divided by kilograms of solvent. So my molality is going to be equal to 0.83 moles of C6H12O6, all this divided by the kilograms of solvent. That, if you remember, we did a conversion in the beginning and we obtained 0.6 kilograms of water. What is the molality of this solution?
1.38.
1.38.
Yes.
And this M is molality is equal to 1.83 M. And that will be the answer of the problem. And that will be it for today's class. Remember, this is going to be homework. And I will add one more, a couple more exercises for the rest. Oh, sorry, my dyslexia. Thank you.